Hi everyone, it's Al, and I'll be talking about classes and objects in Java. Classes are blueprints for code to run. There can be one or many classes in a Java program. They follow this format: public or private, which I'll explain later, class, and then the name of the class, and then braces with the code in between. Methods are, in summary, a reusable block of code that runs a specific set of instructions. They follow a format: public or private, an optional keyword static, a variable type for it to return, or void to return nothing, the name of the method, parameters within parentheses, and a return, unless it's void. All Java programs rely on a main method contained inside of a class. This main method is used to run code within itself and run other methods within the various classes of the program. Here is my main method, and it runs this set of instructions. Objects are single instances of a class, and there can be any amount of them. Objects can be used to store instance methods or instance variables. All objects belong to a particular class, and all of the objects from the same class follow the same blueprints. The only differences between objects of the same class are the values of the variables they store. Objects are declared using constructors. Constructors are a special type of method. They take the name of the class and then parameters. My constructor takes the parameters and gives that value to the instance variables of that object. To initialize an object, I'm doing it in the main class. Here I have two different objects, and it's from the same class, and the only differences are the values of the instance variables. An important set of keywords used by variables and methods are private and public. Private is used for information hiding. In implementation, it means that they can only be accessed by methods of that class. Public, on the other hand, means that they can be accessed anywhere. Private is mandatory for instance variables in AP Computer Science, which is why all these variables here are declared as private. Since they are private, if you were to write my second class .name, you would get an error, and this error says the field my second class .name is not visible. To get around this, we use a special type of method commonly used with objects, and this is called a getter or an accessor. Getters are public. They are the same type of variable as the variable you want to return. They can have any name, and they do not have any parameters, and they just return the same variable. Setters are also an important type of method commonly used with objects. The setter uses a parameter new name to replace the old value of name with whatever you put in. Here I created two objects, and I used a getter to return the first object's name, which is Almutwaggle, as it says here. And then my second line here, set name, changes the name of my friend to Ergen, and then prints it. So if I run this, I'll say Almutwaggle and Ergen. There are some variables that don't vary by object. These variables are called static variables. They belong to a class as a whole. That means that the value is shared between all objects of that class. This is a private static string school. And all objects share the same value. That means both of these objects have the same value at all times for this variable. Even if I were to change this, they would both have the same value as each other for this variable. That's because this value isn't stored inside each object individually. Instead, it's stored inside the class as a whole. This is different from instance variables, which are stored separately in each object. There are also static methods which are shared by the class. This type of method is used for non-object specific actions, which means they can't really access any object specific variables or methods. This is important if you want to run a method without having to instantiate an object first, because normal methods require an object to be created before being able to run. And this is the same reason why the main method is static, because if it wasn't, you'd have to create an object to run this main method, which is not what we want. This is a static method, and this can be called just by writing this line of code: system out print my second class dot my method with the parameter my name. This is different from object methods, because as you can see here, when I say get name, I use the object name instead of the class name. And here I used the class name in my method, because this method is not stored inside objects. There's another feature in Java called method overloading. Methods of the same name can be created if they use different parameters. This is important because method calling is very dependent on exact variable types in the parameters. This is commonly used for constructors. So, for example, I can make another constructor, my second class, string new name without the integer new age. So if I were to run this constructor, I would not have an age because no value was set to that. The age would be default 0. So I can test this out. My second class, third object equals new my second class Jagjit. And if I write system.out.println third object .get name, I should get Jagjit. But if I were to have a getter for age and run that, I would get 0 because no value had been assigned to that. Scope. Where variables exist depends on where they were declared. If they were declared in a class, they exist everywhere unless it's private. If they were declared in a method, they exist only in that method. Same for loop sequences. They only exist within the domain they were created. What this means is that here we have variables that are available everywhere in the class. If I were to make this public, this would also be available here in this other class. But new name here, since it's made as a parameter in this method, It's only accessible inside this method. That means that if I were to write new name here, this would give me an error because this does not exist in this class, only inside the method. I changed a few things so that I could talk about some implementations of the scope. So here, this and this are two declarations for a variable of the same name. They'll have different values, but this one takes priority over this one because this takes a more specific scope than this one. So when you write return age, it will return 0 all the time. Okay, so there's a keyword in Java called this, and what it does is it references to the current object that a method is currently running from. So what this means is that you can use this to specifically talk about an object's instance variables. This is useful. In this case, I used it to distinguish between the name and age from the scope of the constructor. This name and this age takes priority over this name and this age. So when you write name and age here, it's talking about these variables. But if you write this.name and this.age, it's specifically talking about the values from these variables, because these belong to the class, to the object. These belong to the object. There is an important distinction between reference and primitive data types. To explain this, I made a chart. See, this object and this object are from the same class, but they have different values. So what happens when I run this command, second object is equal to new object? Well, instead of this value being transferred over to this value, and the same for this, that doesn't happen. What happens is that calling this object will just point to this other object. So that means that instead of having its own box, it will just share this box with new object. So any changes made here will be immediately reflected in second object. Now there are two different variables that can call the same object because they refer to the same address. Now about null references. Null references are when objects refer to nothing. This can happen if you don't fully declare an object, such as when you type here, my second class, third object. There is not any equals new object name with parameters. If you end it abruptly like this, you get a null reference. When you try to access an object's features through a null reference, you get null pointer exception, because that object doesn't exist yet. Another important note is that when passing variables to methods, they only pass the value and not the reference. This means that if any changes are made to the value within a method, it won't affect the original value outside the method. This holds true for both primitive and reference variable types. So in practice, what this means is that if I were to call my second class .change name, and for given name I give it Al, it would not change this variable into something new. I'll make a variable called string my favorite name is equal to Al. Now if I put my favorite name in here, and print the variable, we'll see if this changes anything, and it shouldn't. It stays as Al. That's because when you change this variable inside the method, it does not refer to the original variable. Instead, it only changes the value inside the method. That about covers everything for the chapter. Now let's head into the questions.